The first thing that you have to do is to find out concentration of your copper ion, which is what I have here, number 2. Number 1, it's the mass that you weighed in the lab, like the mass of your copper acetate. So you should have that number, and that number should be something close to zero point 0.5. Okay? The number right there. And that number is in units of grams. Now to find out the concentration of your copper ion, which is what you have in number 2, I'm moving down here where I have my number 2. Here. Finding concentration, those brackets, they mean molar concentration. So what you're calculating is the molarity for the solution. So to find out the molarity for your copper ion, you need to find the moles of copper. So molarity is the moles divided by the volume in liters. The volume, you have the volume, the liters, because you're preparing that solution in your 25 milliliters volumetric flask. So those 25 milliliters is the same as 0.025 liters. So the volume that you need to find the molarity, you already have that number. What it's missing for your calculation is the number of moles. So finding the moles of copper acetate is what I have down here. So you're going to do your number 1, whatever mass of copper acetate you have, and that's the molar mass, 1 mole over 199.65 grams. That's the molar mass of the copper acetate that you use for the experiment. So this is your grams, which is the number that you have in 1 times 1 mole divided by 199.65 grams. Since your amount in number 1 it's in grams, your unit for grams is canceling out, and what you're calculating is the moles of copper acetate. That number of moles of copper acetate is the same as the number of moles for your copper ion. If you see in your formula, you have copper, Cu is just 1. For the acetate ion, you have 2 of them. But for the copper, it's just 1, which means that the same number of moles that you're calculating for copper acetate is the same number of moles that you need for copper. So now that you have the number of moles for copper, you can calculate the molarity, because that's the number of moles of copper divided by your 0.025 liters. And you have an idea of the number that you're expecting. In your lab manual, the procedure tells you to find out how many grams of copper acetate you need to prepare 25 milliliters of a solution that has a molar concentration equal to 0.1. So whatever number you're calculating here for your molarity, that number has to be close to 0.1. It's not going to be exactly 0.1 because you don't have 0.500 as the mass for your copper acetate. You were weighing an amount that was close to 0.5, but probably you don't have exactly 0.5. So your molar concentration will be close to 0.1. So if you're getting a number that is very different from 0.1, go back and check your calculations. Now that molarity that you're calculating in number 2, that's your initial concentration. So I have that one right there as a C1. It's a number, okay? But that number, it's your initial concentration. It's the concentration of your stock solution, the one that you're using to prepare your 4 standards down here. Remember, you were taking 2 milliliters, 4, 6, and 8 milliliters from your stock solution to prepare the standards. So in your table, you should have your volumes 2, 4, 6, 8. The total volume for all of your standards is 10 milliliters, which is the volume that you have for each volumetric flask. Now the absorbance you have, that's your experimental data, and those numbers, they should be increasing. As the volume here, your volume 1, it's increasing. The concentration that you're going to be calculating should be increasing, and the absorbance should be increasing too, because absorbance and concentration, it's directly proportional. So to find out the concentration that you're missing right here, look, you need to use your dilution equation. The dilution equation, I'm writing that on top right here. It's C1 times V1 equals C2 times V2. Whenever we're preparing solutions from an original solution, we can use the dilution equation to find the new concentrations. So what you're calculating is C2, which is the concentration for the diluted solution. So C1 is the concentration for your stock. B1 is the volume that you have in this column here, your 2, 4, 6, 8. And then your V2 for all of them is 10 milliliters. So if you look at the three numbers that you need here to calculate your concentration, C1 is the same for all four because you're preparing all of them from the stock solution and you have only one C1. B1 is different for all of them. You have 2, 4, 6, 8. And then B2 is the same again for all of them. So you're getting different numbers here, and your different numbers are going to be different because of your B1 in this column here. So I'm going to write down the calculations for one and then you can find the other ones. So I'm going to do my C2 here for the first one. Your C1 times V1, which is 2 milliliters. All of that divided by your V2, which is 10 milliliters. And when you do your multiplication and then divided by 10, that will give you the concentration that you need for that one. Then the next one, you have the same C1 times 4 divided by 10. For the third one, it's your C1 times 6 divided by 10. And then the last one will be your C1 times 8 divided by 10. So you have all four concentrations for the standards. And you have your absorbances. So now with that experimental data, your concentration here for the standards and the absorbance, you're going to prepare a graph. So you see how I have here for the second table, brackets Cu plus 2, that's molar concentration for your copper ion. And I have here from the graph. You have your unknown number from the label, you measure the absorbance, so you have those two. Now you need to prepare a graph to actually get that missing concentration. So in your graph, what you're going to use is these absorbance values here, whatever numbers you have, that goes in your y-axis. And then the concentrations that you're calculating here, your C2s, those are the numbers that you need in the x-axis. So you're doing a graph of absorbance versus concentration. So absorbance in y and then your concentration in the x-axis. And that's molar concentration. So I have here things that you can use to prepare your graph. First thing that you need to know is that when you're graphing, you're not using the same numbers that you have as your data. You have to prepare a scale for each axis. So you need to choose a range that covers all of your numbers, but you're not using exactly your numbers. So I have here an example, and you have to do the same thing for both axes. You don't need to have the same range for both. You need a range for your y-axis that covers your list of numbers, and then you need another range for your x-axis that covers all of your numbers. So I'm giving you an example here. I have values of absorbances. I have 0.188, 0.542, 0.851, 1.273. So those are actually values for absorbance. I'm not using in my scale here. Look at the graph down here where I have my absorbance. You see, I don't have 0.188, I don't have 0.542. I'm choosing a range that covers all of my numbers. My first number is 0.188, so if I'm starting here at 0, 0.188 is before 0.2. 0.542, you see I have 0.6, 0.4, that one will be between 0.4 and 0.6. The highest number that I have is 1.273. So my scale goes all the way to 1.4. So you see, I'm choosing my range from 0 all the way to 1.4. Between that range, I have all of my absorbance values. Now, besides choosing the range, you need to choose a scale, like increments for your scale. So I'm choosing 0.2, 0.4, 0.6. It's increments of 0.2, and that is convenient because you don't have too many data points, and the difference between them is not super big. But if you have data that starts in 0.1 and it goes all the way to 50, you should not choose an increment of 0.2 because you will have to prepare a super long axis for your graph. Starting at 0.1, going all the way to 15, increasing by 0.2. At 0.2, 0.4, 0.6, look how many lines I have, and I'm still at 1.4. I will have to keep going all the way to 50. So the increments that you're choosing, they should be good enough for the scale that you're preparing, for the range that you have. So I'm choosing 0.2 because that's convenient. I don't have too many data points, and my numbers, they go from 0.188 all the way to 1.273. So increments of 0.2, that's fine. So you have to do the same thing for the concentration axis. So you have to calculate your 4 concentrations for the standards. And then based on your numbers, you have to choose your range. And besides choosing the range, you need to choose increments. So now you can actually see why you cannot use your exact numbers. When you're preparing the graph, I'm defining between 0 and 0.2. I have 1, 2, 3, 4. 4 squares, tiny squares. So 4 squares, it's 0.2. And again, I have 1, 2, 3, 4 squares. That's another 0.2. So you're going from 0.2 to 0.4 to 0.6. And I have exactly the same amount of space between them because they're increasing by exactly the same amount. From 0 to 0.2, that's 0.2. So you need to have the same amount of squares between my 0.2 and 0.4 because that's increasing again by 0.2. So I'm defining 4 of these small squares as 0.2. So you need exactly the same distance between your points here because you have an increment of 0.2 between each one. So if you're defining 4 tiny squares as 0.2, you need to have the same amount between all of them. So now you can prepare the graph with your numbers, and you have your own numbers. You have your graph, the scales for the y-axis, the scale for the x-axis, and you need to label the graph. So let's say that let's put some numbers here. For concentration, so I can give you actual dots in here. So if the first concentration that you're calculating it's 0.02 and your absorbance is 0.188, we're going to use the graph to find those two. 0.02, the first one, that's this one right here. and then that one goes with 0.188. 0.188, look, this is 0.2, somewhere right there will be 0.1, so 0.188 should be close to 0.2. So I'm going to put my first dot right there. Second one, 0.04, and that one goes with 0.542. So 0.4, 0.6, 0.5 should be there, and 0.54, it's probably like a little bit lower than half between those two. And that one goes with 0.04, so where those two meet, you have another dot. Where did my, right there. And now we can do the third one, 0.06, which is this one here. And that one goes with 0.851, 0.8, 0.9, 0.85. Somewhere in there. And then the last one, 0.08. And that one goes with 1.2, that's 1.3, lower than that, somewhere there. So I have my 4 dots corresponding to my 4 concentrations and my 4 absorbance values. So now you need to trace a line on your graph, and your line is going to be a straight line passing through 0. You're measuring absorbance, and that absorbance is due to the amount of copper that you have in solution. If there's no copper in solution, then the absorbance is 0. Because if you don't have any copper, you don't have copper to absorb any light, so your absorbance will be 0. So 0 absorbance equals 0 concentration, so your straight line should pass through 0. You might not have all of your dots in that line, but you should draw your line containing as many dots as possible, or having all of your dots as close as possible to the line. That's not good. It has to go through 0. That's better. So I have my line right there. So you have your graph. Look, you have graphing paper, square paper. At the end of your lab manual, the last pages, you will find graphing paper. So you should use that paper to prepare your graph. Now you need this graph to find the concentration of your unknown. Okay? So you have in your table unknown number, in the label you copy that number, you measure the absorbance, and you have that absorbance. So I have here let's say that your absorbance for the unknown, and this is my example, this is not your number. Let's say that it's 0.632. So to find the concentration that corresponds to that number, you're going to find that number for absorbance in your absorbance axis. So this is 0.632, so I have 0.6, 0.8, 0.63 should be a little bit higher than 0.6. From that absorbance value, you're going to move to the line that you have. You see how you're preparing your graph. Your first dot is where your concentration meets your absorbance value. The second one, concentration meets absorbance. The third one, concentration meets absorbance. The last one, again, concentration meets absorbance. So if you have your absorbance here in the y-axis because you measured that one, You can go from your absorbance value to the line, and from the line down to where the concentration is. So where those two meet, no, that's your concentration that corresponds to that absorbance value. So now you can estimate that's zero point 0.4, that's zero point 0.6, and it's like close to the middle between those two. It's close to 0.05. And remember that's molarity, or capital letter M. So that's how you're going to find the concentration of the unknown using the graph.